Hello guys, Assalamu alaikum, and today we will discuss wireless sensor network. I think we have already discussed a part of wireless sensor network, so this is the second part, and probably we will have third part as well. So today we have those topics: structure of a wireless sensor network, wireless sensor network topology, routing techniques for wireless sensor networks, routing challenges affecting the wireless sensor network routing. So let's start. Okay, last time we discussed IEEE 802.15.4 standard, and you know this is the standard designed for short range wireless transmission protocol, and this protocol defines physical and MAC layer, and there is no specification for higher layer like network layer and application layer. So today we will discuss ZigBee standard. So the ZigBee standard is developed on top of IEEE 802.15.4 standard and defines network and application layers. So with the combination of IEEE 802.15.4 and the ZigBee standard, we will have 4 layers: physical layer, data link layer, network layer, and application layer. And what does the network layer do? If you recall the OSI model that you all, I hope you guys have gone through with the OSI model in your in college. So the network layer is, there are many responsibilities, but one of the function of network layer is routing. So routing means finding a path, an optimal path from source to destination to send data. So the two protocol stacks can be combined together to support short range, low data rate wireless communication with battery powered wireless devices. Here I would like to emphasize a few things. I have already told you about this, but I want to repeat that so that you guys keep those things in mind. So when we are discussing wireless sensor network or IoT infrastructure, we have some limitations. Number one, we have nodes which has low power, which has memory limitation, and which have processing limitation. So keep this in mind, and we will discuss its topology, because those things affects the topology, the routing. This network, the wireless sensor network, is not like internet or other our networks like wide area networks or metropolitan area networks, local area networks. Alright, so let's move on. The potential application of these standards mean ZigBee standard include sensors, interactive toys, smart badges, remote control, and home automation. ZigBee protocol stacks was proposed at the end of 2004 by ZigBee Alliance, an association with companies working together to enable reliable, cost-effective, low-power, wirelessly networked monitoring and control products based on an open global standard. Okay, so the ZigBee is a short-range wireless transmission standard, and the range of the ZigBee started from 10 meter 100 meters. So one ZigBee module can send data 10 meter to 100 meters. So why there are not a fixed limit? This is based on the environment. Like if you are using indoor in a house where you have thick walls and other so if you use it in a house, the range will be around 10 meter, as I told you, because of thick walls and stuff like that. But if you use in outdoor environment, the range could be 100 meters. So ZigBee communication is specially built for control and sensor network on IEEE 802.15.4, and as you know, it is a wireless ZigBee support wireless communication. So whenever there is a wireless communication, then that will be used some carrier frequency. So the ZigBee operates at 868 megahertz, 902 to 928 megahertz, and 2.4 gigahertz frequency. So these are three set of frequencies over which ZigBee operates. The data rate of ZigBee standard is 250 kilobits per second, and the ZigBee standard is less expensive and simpler than other proprietary short-range wireless sensors like Bluetooth and Wi-Fi. So as compared to Wi-Fi and Bluetooth, it's simpler and less expensive. So that was just a small introduction of ZigBee. We have a separate topic on ZigBee, and we will go through with those topics in coming slides. Today we will discuss wireless sensor network. Okay, so this is a scenario of wireless sensor network. When two nodes are involved in communication, wireless communication, one node sends data to the second one, and second one sends data to the first one. This type of connectivity is called point-to-point connectivity, and the range of these would be, as I told you, if it is a ZigBee device, then if the communication technology is ZigBee, then these nodes can communicate within a circle of 10 meter to 100 meter, but they cannot communicate with each other beyond 100 meters because signal cannot be strong enough to cover the area higher than 100 meters. So let's see if this is a node and it sends a wireless electromagnetic waves. So with the distance, as it passes the distance, the signal strength becomes weaker and weaker, and at one time you will not differentiate that which one is the positive side and which one is the negative sides, and we will have a smooth line, which means there is no information, no productive information. So we have, if this is 100 meter, so this will be the range. We cannot go beyond this. To go beyond this, we have some intermediary nodes. So if we have another node here, the ZigBee enabled node, and another one, so you can expand your coverage area, and that is called multi-hop, multi-point communication. So you can see the example. A want to send data to sync. It cannot send the data to sync directly because the range is not, the sync is placed away of the 100 meter. So what it does, we have many nodes A, B, C, D, and along with other node as well. So now we have many nodes. So this is a sensor node, and that is the sensor field, and this is sync or gateway, sometimes we call it gateway, and here is the internet. And now you can see from A to E there are many paths. So one of the path is this one. Another path could be this. And still another path could be this one. We might have this path. So from A to sync there are many paths. So which path it should follow? This is called routing. It is a process to select the best path from A to sync in our case. So if when we have multi points, so to connect those nodes with each other on the basis of the layout of these nodes connectivity, we have some topologies. The one is called star topology, and those are the topologies I know you guys have learned in your college. In star topology you have base station and you have remote nodes. These are the remote nodes. So these are the nodes, and this is a base station. So nodes are communicating with the base station, and the base station in return is connected with some other base station, or it might be connected with the sync. So if these nodes have some data to send to the sync, they will not allow to send directly to sync. Rather, they have to send it to base station, and the base station is responsible to send to sync. And another one is that the remote nodes, those nodes, they will not communicate to each other. They will communicate each other via the base station. So this is a simple star topology. I know you guys know about this. And the advantage is that it's simplest one, and the disadvantage is that the whole network will rely on the base station. If the base station is failed, the whole network will be down. Another one is the mesh network. A mesh network consists of a gateway node, simpler sensor nodes, and sensor or router nodes. All network nodes can connect directly to each other in a full mesh technology. So you can see we have mesh topology. So this is gateway, and these are the sensor node or routing. These are the sensor nodes, and these are sensor nodes or routing, and these are the edge nodes or sensor nodes. And you can see here one node can be connected to two of the base station. Advantage is that simultaneous up and downstream communication is possible here, and we can expand or modify this network without disrupting or without stopping whole network. This network topology has the advantage of redundancy and scalability. Redundancy means this in this topology a source will have many paths to reach to destination. And scalability means that you can add or remove the node without stopping the whole network. So, or in case if one node is failed. So the question is that why the one node will be failed? The thing is that wireless sensor network has nodes. In IoT we have sensors, and these sensors are miniaturized sensor, means small sensors, and they are cheap. So they are built with cheap materials, so that they should be expensive. So there are more chances to to that there comes malfunctioning or some hardware failure. So whenever a node failed, the network shouldn't be down as a whole. So the mesh network has that scalability that if one node is failed, then the network still be in functioning. And another one is that the benefit or advantage is that the network is not limited to the range of individual range. So you can increase the coverage area by adding more nodes in between source and destination. You will cover larger area. The disadvantage is that there is redundancy. At the same time, it was the advantage, and at the same time, it is a drawback as well. Redundancy, and there are many connections, and overall cost is higher and more labor-intensive setup, and the maintenance is required, and the troubleshoot is if there is a problem, then you have to find out. The troubleshooting is a bit complicated. Right? Another one is that the network is power consumption for the node that implement the multi-hop communication. So if we have the base station, will be we have base station with higher power, and as the network coverage area is higher due to multi points, then the latency will be higher as well. So it will take more time to deliver data from one end to another end. It's very obvious. Hybrid star mesh network, you guys know that, and I think I'll leave that slide to you, and there is no new thing. Alright. As I told you, with single hop there are two modes of communication. Single hop, one node is directly connected to the sink, and another one is one node is connected with sink through many nodes, multi-hops you can say. So multi-hop communications, I pointed out an issue that in the second slide, that if there are many paths from source to destination, so how to select the best path to get to this destination. This is called routing techniques. And the routing techniques that we are familiar, if you guys are familiar with internet or local area network or wide area network, the routing techniques they are using are not suitable to wireless sensor network, because for routing normally we have router that maintains those things. So I'll explain it in the slide. Alright, so for example we have node this and this and this and this, and this is A, this is B, this is C, and that is D. So A is connected with D, and it's connected with C, and then it is connected with this and this. So the A must maintains a table that shows that this is the A table, the routing table. A will maintain that which one is the immediate neighbor, the D. D is the immediate neighbor of A, and there is one, you can say one point or one hoop. And how about C? A can connect to C via D. Let's see how to do this. Let me remove that. There So A can go to C via D, and there are two hoops. And similarly, A has a neighbor B, but it's not directly connected. It is connected to D, and it is two hoops away. Similarly, the B will also contain a list, and C will also contain the list, and the D will also contain the list. So whenever we add something, some new link or some new node, so all of those nodes will update the routing table, and same will apply when we remove a node. Whenever we remove a node or remove a link, so all the nodes in the network will update their routing table. So if consider in internet brings the envisage internet. So the internet is a huge collection of a huge number of nodes, computers, hosts, switches, routers. So every node will have like millions of routing tables if they follow the same procedure, and that is an extra overhead thing. So for this they have routers. Router is a special type of device. Router, it has its own huge memory. It has own CPU. Processing is higher. It is powered by direct power lines. So for routing, for this purpose, they have a router. And in wireless sensor network, we cannot have afford routers in our wireless sensor network. So the topologies for routing that we have designed for internet, we cannot use it in wireless sensor network. The wireless sensor network has its own topologies we will see in a minute. Let me remove all these. Can I remove that at once? I don't know. Alright, so here there are some challenges, routing challenges that affect the wireless sensor network routing. And what are those challenges? Number one is the energy consumption. Energy plays an important part in wireless sensor network. And in wireless sensor network, it is not necessarily for all nodes to have powerful energy. There are some nodes that have more energy, and there are some nodes that have less energy. For example, can we go back? Okay, no. For example, there is a node, and this is the sink. This node is a temperature sensor node, and it sends the temperature of some area. Let's suppose this area. This is you can say a room. So will that be a wise approach to send temperature of every 1 second? When you send data, it will use that channel, and the gateway will need a huge memory to store those temperature values. So for 1 minute, the gateway will receive 60 readings, because you are getting temperature value after every second. And the temperature doesn't change in a second. So it is not a good approach to send data every second. And even, let's see, 1 minute. The 1 minute is also not a good approach. So we want. So how about if we send temperature value after every 15 minutes? Yeah, that's you can say a bit. This makes some sense. So every 15 seconds you will get data. So in 1 hour you will have 4 values, rather than the 60 values. In 1 hour you will get 3600 values if you are using the resolution of the temperature is 1 second. You will get 3600 values in an hour. While if you keep this to send data to 15 minutes, in other way, if you keep the resolution 15 minutes of the temperature sensor transferring the data, then you will have 4 values in an hour that represents what is the temperature, and it would sense the change. So if the data is sending after 15 minutes, how much time it will take to send the data? I think it would be less than a second, or you can say just 2 seconds. So the data will be sensed and sent in 2 seconds, and the next time it will send after 15 minutes. Okay, the data will be sent in 14 minutes and 40 seconds, not 40 seconds, 58 seconds. So in first 2 seconds it will send the data, and the next data will be sent after 14 minutes and 58 seconds. So during this time, this node will do nothing. it will be idle. So it is not necessarily for this node to use power, to use energy. So we will make it, what we're gonna do to save the energy, we will keep this node in sleep mode, for that much time. So when this node is in sleeping mode, it will not use much power. It will use the power only when it needs to send the data, and that time will be 2 seconds. And in contrast of this node, the gateway, this is the gateway, it is receiving from different sensor nodes. There are a lot of sensors. So this node shouldn't be in sleeping mode. This should be alive every time because it has to receive the data. So this node needs the power continuously, but those nodes, they don't need much power and they have to sleep. So I want to try to explain that in wireless sensor nodes, there are some nodes that needs less energy and there are some nodes that have more energy. So when we have that sort of scenario, so while deciding which path should we follow, should we take to send data from source to destination in multi-hop networking, we will consider that in this path the nodes involved in this path has more energy capable nodes. If there are more energy capable nodes, then we might have followed that path because those nodes have higher energy and they can send data more accurately to a maximum distance. And if a node has less energy, it won't send data to the maximum distance, because at certain distance the signal strength will be fall, and your data will not be accurate. Okay guys, so this is a challenge while deciding the routing in wireless sensor network. So energy consumption is a challenge. We need to consider that. Let's move. Alright, so because of this constraints over energy, most of conventional routing metrics like shortest path are not suitable for wireless sensor networks. Okay, so remember that the shortest path in internet, sometimes we use shortest path first because it will take less time, but in wireless sensor network this is not sole criteria. There are some more matrices as well. Dynamic state of network. Another thing that give us challenge is that in conventional network the nodes are static. Static means in spatial parameters, in spatial perspective, they will not change the place. But in wireless sensor network they are miniaturized. There might be a situation where you can take this node and place it some other location, and to change the location it will also affect the routing, it also affect the path as well. Robustness and failure intolerance. So this is another parameter. We should consider that while considering routing for wireless sensor network. This means that routing is performed by routing protocol that are operated on sensor nodes instead of dedicated routers. These sensor nodes consist of low-cost hardware as compared to dedicated routers that may cause of unexpected failure in sensor nodes. If a failure occurs, then your network, wireless sensor network, should be robust enough to to afford that failure and respond quickly to get another path. Scalability is another thing that if you want to add or remove the nodes, it shouldn't affect the routing topology, routing protocols. Node deployment. Another challenge while doing routing for WSN network, wireless sensor network, is the node deployment. So there are two types of node deployment. The one is pre-planned. You have planned it, and before building the network, you have placed network nicely with some survey. Like if you are placing wireless sensor in the buildings, you can see that it will cover that area, and that will cover that area, and this cover that area, and so you know how to place those so that it covers maximum area of this room. So you have well planned for this, and you placed it according to your plan. And another approach is the randomness. You have no information about the network topology, you just place it randomly, and that sort of network will be unstable. So routing protocol should provide topology information such that the neighbors of each node are discovered and routing decisions are made accordingly. Matrix. Routing protocol decision about the best route selection among multiple routes is based on the type of route matrix. So what matrix you're gonna use in your real life when you move from your house to university, and if there are two paths, the one path is 4 kilometers and the other path is 10 kilometers long. So you obviously select the path that has less distance, like 4 kilometers. So selection of path based on the distance. So here the matrix we use the distance. So distance is the matrix to select the path. This is a simplest one. But in wireless sensor network, we have some more matrices as well. We are not just only consider this the link cost. This is called the link cost. We will consider congestion, delay, energy. For example, this is congested one, and this is not congested. Now, based on congestion, you might select the longest path. You will say that this is longer path, but it is not congested. And there is another one is the delay. It is the shortest path, and everyone want to compete to get that path. So if that path is congested, and the time to deliver data from here is 10 minutes, while this is not congested one, and it takes like 8 minutes to transfer to deliver the message. Then on the base of delay, or the base of time, you will take that path, the long one. So these are some matrices. I told you okay. So another matrix is the energy. If from source to destination, let's suppose you have two paths. In path A, you have 2 nodes. In path B, you have 4 nodes. And you can see in path 2, path 2 is the longer as compared to 1. And you put another condition, which is that in path 2 all the nodes, node 1, 2, 3 and 4, they have higher power nodes. These are higher power node and these are lower power nodes. Based on this, you will certainly, the link will be labeled with energy. So if you sum up them, and if the energy is higher than this, then you will follow this path. Alright, so expected transmission count. So expected transmission count is actually the expected number of lag layer transmission necessary to successfully deliver a packet through a wireless network. The weight of a path defined as the summation of ETX of all kinds of all links along the path. So look, let's see the same example here. So expected number of transmission necessary to successfully deliver a packet. Let's suppose from this point it takes the number of MAC layer transmission necessary to successfully deliver a packet is 2, and here is 1, and here is 2, 1, and then 2. And this path has the number of transmission necessary to successfully deliver the packet is 5. Let's suppose 5, and this is 6, and this is 6. So how much is the sum? This becomes 12, and so 17. So this path has ETX of 17. And this path has 2, 1, 3, 5, 6, 8. This path has ETX 8. So the path that has less ETX will be the best path if you are considering the matrix of ETX. Another matrix count in wireless sensor network to select a path is expected transmission time. Expected transmission time is an estimation time cost of sending a packet successfully through a MAC layer. It takes the link bandwidth into account and commonly used to express latency. So let's take the same example. We have source and this is destination. One path is this, and this path has those nodes, and this path has this path has 2 nodes. So the time taken by this node to this node to successfully transfer the data is 1 second, 1 second, 2 seconds, 1 second, 1 second, 1 second. So the whole the expected transmission time would be 2, 1, 3, 4, 5, 6 seconds, and we're just assuming that it takes 3 seconds, 3 seconds, and 4 seconds. This would be like 10 seconds. So which path would be the best if we have expected transmission time as a matrix? Then obviously this path would be the best to select this to send our data. There is one more thing, is the bandwidth. it is taking less time than this, while obviously this path is longer than this one. So one possibility would be that the bandwidth of this path is higher than this one. And how? I'm just taking a scenario that paths from this source to destination, they are using fiber optics, and the path using this the path from source to destination, and this the medium is twisted pair. You know, twisted pair has very less bandwidth as compared to this. So the higher bandwidth will take less time to send it. Okay, so routing protocols for wireless sensor network can be classified in different ways, and most prominent ways are based on network structure, route discovery process, and protocol operations. So based on these three, there are different routing protocols. And in network structure, based on the network structure, we have flat-based, hierarchical, location-based, and on the route discovery, we have reactive, on-demand, proactive, and hybrid, and on protocol operations. So finally, some of the routing protocols can be classified with respect to their operations, like quality of service based, query based, and negotiation based. So then the last one, protocol operations, they are based on quality of service, query, and negotiation based. So guys, we will next individually will discuss those one by one. Flat, hierarchical, location based, and if we have time, we will discuss others as well. So these are flat and data centric routing protocols. So in flat, we have those routing protocols: flooding, spin, directed diffusion, remover routing, gradient-based routing protocol. So in the next slide, in the next lecture, we will go through those topics. So up to that, take care of yourself. And if you have any query, guys, if you have any query, you can WhatsApp me. You can send me a message. If you have some confusion in this lecture or in previous lecture, I will try to explain it to you. Thank you very much. Stay safe.